In this video for day 9.3, we'll be talking about probability with combinations. And so we'll be talking about combinations like we did in lesson 9.2. Okay, the symbol for a combination of events, or the notation rather, is NCR, where N is the total number of events to choose from, and R is how many of those we are making a combination of. And so we're going to be talking about combinations with additional criteria. What that means is some special rules we would have to follow in making our combinations. And there's really this idea of what we call compound events. Okay? Rather than just simple single events, we have compound events. And there's two ways we can group more than one event together. That's really what we're talking about, more than one event together. There's two ways we can group that together, either with what we would call a union, which is where we use the word and to link them together, the event A and event B, okay? Or with the word or, okay? In each case, we have a different set of operations we would do. Anytime our compound events use the word and, or meaning that both or all or however many are happening together, that is a situation where we multiply to get our total. But if they use the word or, we add to get our total. So in our first set of examples, we're going to look at a situation where we have more than one set of combinations to consider. So here's the problem. There are 65 students in geometry. Mr. Allred wants to form a committee of 8 students consisting of 4 males and 4 females. There are 30 females and 35 males to choose from. How many different ways could he form this committee? And so we have really two combinations to consider. We have our combination for males, and then our combination of females. And since in this committee he wants to form a committee of 8 students consisting of 4 males and 4 females, there's that keyword and, we are going to multiply are 2 separate combinations. Okay? And so for our males combinations, we have a total of 35 males to choose from. And so we're going to do 35, a combination of only 4 of them. We're going to do that combination times our combination of females. We have 30 females to choose from. We're going to do a combination of 4 of them. Okay? And then we're really just going to plug these into our calculator to get our grand total. We'll have some large numbers with a lot of these. So what we're going to do is we're going to do this combination in the calculator and this combination in the calculator and multiply them. Now we can do them separately or all together, and I'll show you what I mean. So let's do the first one. We can use our calculator shortcuts for these to save us quite a bit of time. We're going to do 35. Then we're going to remember to go to the math menu, over to probability, and we want a combination, so that's option 3. And we're doing 4 as our number of the total 35. Now I could just hit enter here and get that number and write it down. 52,360. And then I can go on and do my combination for the females. So we do 30, math, over to probability. Oops, I hit the wrong one. Let me back up. Math, over to probability, and we want option 3 again. And I want 4 of those. And we get a total of 27,405. And when I multiply those together, I get a total of 1,434,925,800 possible combinations with that criteria of 4 males, 4 females. Okay? So in our next example, we've got Barb here, and she has a petting zoo where there are 6 horses, 4 donkeys, 8 goats. And then from those total of 18 animals, if I add those up, I get 18 animals. She's planning on taking 10, total of 10 to a birthday, but there's a specific request that needs to be followed. Those 10 need to be 4 horses, 4 donkeys, and 2 goats. So how many different combinations can Barb make? Well, we've got a combination for horses, and then a combination for donkeys, and then a separate combination for goats. And so I'll kind of color code that as we work through it. So we've got, let me choose the red one first. For our horses, there are a total of 6 horses to choose from. So I'm going to do 6 with a combination of 4. We're going to multiply that by our combination for donkeys. There are 4 donkeys to choose from. We're going to do a combination of 4 of them. And then lastly, there are 2 goats. Well, we have 8 goats to choose from, so that's going to be 8 combination. Only 2 is what we're going to bring. The bigger of our 2 numbers we can work with, our total number, is always going to be the first number you write, remember, for combinations. Now, as we go through this, I want you to remember from last lesson, when I do a combination and I use all the possibilities, that really is just 1. So this in the middle really kind of just gives us a value of 1. But I can actually put all this in the calculator and save myself quite a bit of time as long as I use parentheses correctly. Okay, so we're going to put each one of these in parentheses like that. Parentheses, 6, math, probability, option 3, only choosing 4 of them, in parentheses. And then we're going to do this one in parentheses, 4, math, probability, option 3, all 4. And then another parentheses for the goats, 8, math, option 3 for probability. We're only choosing 2 of them. Okay, so when I put all those together in the calculator, it gives me my final answer all at once. Okay, and just using parentheses with your multiplication implied between each set of parentheses gives us our final answer, 420. So there's only 420 combinations with those specific criteria. So now we're going to take a look at actually calculating probabilities where there are combinations with the additional criteria. I want you to remember that the probability of some event happening is your favorable outcomes, okay, or your favorable combined outcomes, out of or divided by the total possible outcomes. All right, and so these are going to be combinations in all of this fraction, and so we're going to definitely require our calculators to do a lot of this work. But I also want you to remember that the probability of an event not happening, we called that the complement probability, was 1 minus that the probability of the event did happen. Okay, that's how we get our probability that the event will not happen. Okay, we do subtraction from 1. And so we can use that for a lot of our work as well. All right, so in our first example, part A, we're going to go through some of these, but not all of them. In our first example, there are 65 students in geometry. Mr. Allred wants to form a committee of 8 students. If there are 30 females and 35 males, find the probability that the committee has 3 female students. Okay, and so what that means is, if there are 3 female students, the committee is still going to be 8 students. We have to have an additional 5 male students then to get our total of 8 students. All right, so we have to do a little bit of work to set this up. So the top of our probability fraction, or the probability of 3 females, is going to be our combination of females and combination of males out of the combination of all students. So our combination of females, let's do that one first. There are 30 females to choose from, so that's 30 with a combination of 3 of them, times the combination of males, because this is an additional criteria. Well, there are 35 males to choose from. We're going to choose 5 of them. So I want just those combinations out of my total possible combinations of all students, doing 8 of them. So that would just be a total of 65 students doing a combination of 8 of them. So the individual pieces use the individual piece numbers, and the total on the bottom uses the total numbers. 65 is your total number of students, 8 is your total number of your committee. Okay, you'll kind of notice at the bottom then, these numbers are when you add male and female, the 2 separate categories. But on top, we had our female combination and our male combination listed separately, because those are favorable outcomes. And so then again, it really does become just what we can put into the calculator. So if I typed that in parentheses and that in parentheses, divided by that in parentheses, it would give me my answer. And so we can set that up like this. Parentheses, 30, combination 3, parentheses. You can hit times if you want, you don't have to. Times 35, math, probability, option 3. Combination 5, so 35, we're choosing 5 of them. Close that parentheses, divided by your total, 65. I need to put that in parentheses, hold on, back, parentheses, 65. Math, probability, option 3. We're choosing 8 of them. Close your parentheses. That is all of that in the calculator. Hit enter, and we get about 0.26. Remember, probabilities need to be between 0 and 1. Okay, or as a percentage, that would be about a 26% chance. So let's see if we can set up another one. We have the same scenario, but let's say we want a committee that does not have 3 female students. Now this is where this gets a little bit tricky, okay? I could set this up separately, but listen. This is a probability that a committee does not have 3 female students, which just means it's the complement probability that a committee does have 3 female students. So we can make this a whole lot easier by thinking of it like this, as a complement event. Okay, that's simply 1 minus the probability of 3 female students, which we just calculated. So that's 1 minus 0.26. When I do 1 minus 0.26, I get 0.7388 or 74. Okay, if I use more exact values, it looks a little bit different, but that's what it rounds to. So we don't want to forget our ability of using the complement probabilities. Okay, we're going to skip over part C because we would do that a lot like we just did. If there were 7 female students, that means there would only be 1 male. So I would do 30, choose 7, and 35, choose 1 out of the same total. It's going to change your answer a little bit, but you're really just switching out some of those numbers. We're going to skip down to part D. Okay, same section here, but we want to look at the probability that the committee has at least 4 female students. All right, now we're going to try and take a look at this and do it one piece at a time, because this at least phrase really changes things. So, at least 4 students that are female means greater than or equal to 4 female students, which means I could have 4 females, and it's a committee of 8 again, so that'd be 4 males, or 5 females and 3 males, or 6 females and 2 males, or 7 females and 1 male, or all 8 females and no males. Okay, so really we have a lot of combinations. Now, there would be 1, 2, 3, 4, 5 individual pieces to add up. But at least 4 also means not at most 4. Well, at most 4 would be 3 or less, or not at most 4 would be 3 or less. 3, 2, 1, or 0. So there's 4 options to check this way, and 5 options to check this way. It doesn't really make a lot of difference. But since we are using this phrase, you'll notice if you were listening that I said or. Okay, we're doing 4 and 4, 5 and 3, 6 and 7. I'm sorry, 6 and 2, 7 and 1, or 8 and 0. That's an or option. Since we use the word or, we're going to have 5 individual probabilities that we add together. And so I'm going to show you how to set this up. Okay, the probability of choosing 4 females, 4 males would look like this. We had 30 females to choose from. So it would be 30 choose 4 times 35 males choosing 4 of those, all out of 65 choosing 8. But then we're going to add that to our other individual probabilities. We would do 30 choose 5 times 35 choose 3 divided by 65 choose 8. Sorry, then we're going to add that to these other options. 30 choose 6 times 35 choose 2. See how these two numbers always add to 8? Over 65 choose 8, and these first two numbers always add to 65. We're running out of room. Plus, we've got 2 more options. 30 choose 7 times 35 choose 1. Over 65 choose 8. Plus our final option that we're taking 30 and choosing all 8 females times 35 choose 0. All over 65 choose 8. And then to do this problem, we are going to go through and we're going to find the individual decimals, and then we're going to add them all up. So first, we're going to do this top one using parentheses, 30, math, option 3, choose 4, 35, math, choosing 4, divided by 65, math, choosing 8. Okay, and we get that individual probability is 0.2843 approximately. And so what I'm going to do is I'm going to divide these out with a calculator and write these decimals. I'm going to pause the video so I don't eat up a lot of your time and just write what these are, and then we will add them up. Okay, we have all these decimal probabilities for whether we're choosing 4 and 4, 5 and 3, 6 and 2, 7 and 1, or 8 and 0. So that's your last probability there. So we're going to add those all up. 0.2843 plus 0.1848 plus 0.0700 plus 0.0141 plus 0.0012. And we get a total probability combined that you have at least 4 female students and 4 males as 0.5544. Okay? And so we're going to do some more with this phrasing of no more than or at least or those kind of things later on. So let's keep on moving to our next set of examples. Okay? And this is very similar to what we were just doing. All right, so I'm going to talk about some of these but not go all the way through. So Barb has a petting zoo again, 36 horses, 28 donkeys. She's planning on taking 10 animals to a birthday party. Find the probability that she will take 5 horses. Well, if she takes 5 horses, she's got to take 10 animals. We're only breaking this down into 2 groups this time. We've got horses and donkeys. So 5 horses out of the 10 means also 5 donkeys. All right? So that would be our combined for the first option would be 36 horses doing a combination of 5 of them times 28 donkeys, doing a combination of 5 of those, out of our total number of animals. So if we added those two numbers together, 36 plus 28, that's a total of 64 animals. We're doing a combination of 10 of them. And we can enter that in the calculator like this. And we get that that is about 0.2446 for our combined probability. Okay, so when it asks what's the probability that she will not take 5 horses, well, that's simply 1 minus the result I just got, which means we get a total of 0.7554 for that probability.